All right, so so we spent quite a bit of time in on being able to query, to query data. Let's spend some time talking about updates, being able to update the data, which is a little less exciting, We're just modifying things that already exist, but just to have a minimal understanding of what we mean. By updates, we mean anything that has to do with to either creating new data or manipulating data that already exists or removing any data, So those three operations, creating by inserting, updating, or deleting data, So alongside with selects, that gives you the four major operations that you can do in any database. The CRUD operations: create, read, update, and delete. So let's talk about each one individually. So the syntax for insert, as you might know, it's that you insert into a particular table, and then you provide the values that you want to insert into that table. Now there's two syntheses. One is the where you only provide the values, whereas in the other syntax you provide both the name of the columns and you provide the names of the values themselves, when you don't provide the when you provide the both the columns and the values, it's very explicit, You're saying that for this particular column, I want this value, and so on and so forth, When you don't provide the columns, then the order in which you provide the values is very important, It has to match exactly the same order in which the fields were declared in the create statement, So the order is implicit. It's implicit based on the creation order in the table. If you use the one where you provide all both the name of the columns and the name of the values, then the order doesn't matter. You can change the order in whichever you want, and also you can skip. You can say, well, some fields might be optional, and you might just omit them from the insert, So if only three out of the 10 fields were required, those are the three that you would provide, in any particular order that you want. It's you can mix and match. Also, if you provide if you use the one where you don't provide the name of the columns, you need to consider that some of the values are automatically generated. For instance, if it's auto incremented, or it's identity where the value automatically increments to the next one, that means that any values that you provide will be ignored, They want to be taken from a particular sequence or taken from automatically calculated and incremented for you, So for that, even though it's automatically calculated, you would need to still provide it, so that it knows what the order of the fields are, So it would be okay, for instance, to provide a null value, for fields that are auto incremented or from a sequence, So things to consider. So here's a quick example on inserting a record into a table. In this case, we're inserting into a persons table this new record of Boone. So notice that it's shown at the bottom, But the actual order of the records is irrelevant, You should not you should not assume any particular order of the records, Even though, for instance, Oracle does provide a row num. Okay, it should never be assumed that you have access to that, the storing of the data is not guaranteed, The database can do whatever it wants with the actual physical order of the records. Here we are providing only a partial subset of the fields that we're inserting, only the PID, last name, and first name, and we are not providing the last two, the address and the city. Presumably those are optional; they're not required. Whereas these are not null, and we have to provide the PID, last name, and first name. Here we are just to point out that if you are providing the name of the fields and the values, that they have to match, They have to match with their intent, their data type, right? Right, in the order that you provide. If you don't provide the value, the other fields take the default value that you might have declared in the create statement. You can also insert from a select, right? A select statement can retrieve data, perhaps from multiple tables, right? Maybe it could do a join, right? Gather information from multiple tables, and then use the output of that select statement as the input into an insert, right? So you might identify that and say, well, maybe that's a bad idea, right? Since the data already lives in these tables, right? It would perhaps be a bad idea to copy that into a table and make it redundant, right? Where those values can be already retrieved from somewhere. We would be perhaps committing a denormalization of the data. We spent a lot of effort normalizing the data, splitting it up into multiple tables, and now we're kind of going backwards, right? We are denormalizing the database by combining multiple tables, right, into one single table. There might be cases when this might make sense. Most of the time, it does not. Where a better alternative might be to create a view, as we'll see a little later, right? That instead of creating an actual table, right, we would create a virtual table, right? That we name this query, we give it a name, and then we can treat it as if it were a table, right? So that we can operate on it just like we would any other table. Here we are just a couple examples on creating a table, and then using a select statement that reads from multiple tables. In this case, it's reading from the student table and the department table, gathering information from both, right? Joining it where the majors match the student and the department, and then using the output of this select statement to then feed this alumni table, right? So that based on a particular criteria, that the graduation year is a particular value, so that we know that you've graduated already, right? So that you are considered to be an alumni of the school. Again, a better alternative perhaps might have been to create a view called alumni, right? That reads from all this, and then we could treat it as if it were an actual table. Nevertheless, it's an option. Here's another example of doing a select statement that is then used to populate another table. All right, delete statement. The delete statement, as the name suggests, allows you to remove data, and typically you say the name of the table where you're retrieving it from, and typically you also accompany it with a where clause, right? Meaning which records you want to remove, the records that meet this particular criteria, right? That if you don't provide the criteria, the default interpretation is that you want to remove all the records, right, from the table, right? Most databases will stop you, right? Will verify and will have configuration to not allow deletes in such a way, and it says, are you sure? Is this what you want to do? You want to remove all the database, the entire rows? More commonly, you want to identify the subset of rows that you want to remove, the ones that meet this particular criteria. Right, so the where clause behaves just like in a select statement. Here is an example where we are calculating all the section IDs based on a subquery. Notice that this is a select statement that is returning either an individual value or a list of values. In this case, it's a list of values that is then used in an outer query that identifies the records that we're going to remove if the section ID is not in here. Meaning, I want to remove any sections where there are no enrollments. Right? Find me all the enrollments, right? And if the sections if a particular section is not in that enrollment table, that means no one enrolled in it. So let's remove it. Let's remove the section from there. Right. So that's delete. Then there's update, like the name suggests, allows you to change the values of records that already exist in the database. You identify the table that you want to modify, the operations that the actual fields that you want to modify, the new values that you want to set them to, and then the where clause, identifying exactly which record out of the million records, right, out of the thousands of employees, which subset of employees do you want to give a raise, right? So this particular team was very, very productive this quarter. Let's give this particular department, this particular team, a raise. If you don't provide the where clause, then you would be giving a raise to everybody, right? To the entire company, right? Regardless of what department they are or regardless on their particular performance, right? So the where clause, again, allows you to identify specific records that you want to update. Here's an easy example. We're going to update the address of Edward Norton. At first, we didn't know where he lived, so now we know. We go back to the original record. Once we identify the record, we can then modify the particular field in that record. Here, right? If we don't, if we kind of forget the where clause, right, we're going to end up modifying all the records in the table, and that's probably not what we had intended to do. This is just pointing out that in your update, you can refer to the current value, right, the current value of a particular field, and you can use it to update it to the next value, right, which is pretty cool, right? You're going to say the new graduation year will be whatever the graduation year was plus 1, which is pretty cool. Not all databases allow you to do that. The earlier version of MongoDB, for instance, they allow you to do that. Right? You would identify updates, and in the update you cannot reference the current value of the field, so that you can calculate the new value that's going to be updated to. Unfortunately, I believe they fixed that in the latest version. But again, it's non-trivial, right? That's pretty cool that you can refer to previous values to calculate the next value. All right.